Yes, now I'll show you how you can solve the second assignment in assignment number 3. So I'll take a print screen of this. Yes. Yeah, a good idea could make a sketch where you add numbers for the different forces. For instance, this is F1, F2 and F3. I have not done it here, but I just recommend you. So I'll put in all the known things. So I start this F1, F2, F3. So F1 is, it's at 2.5 kilonewton. Then F2 is 2 kilonewton and F3 is 3 kilonewton. Now I also have the different angles. I have 30 degrees for F1 and 20 degrees for F2 and 60 degrees for F3. So I'll give them the name alpha 1 is 30 degrees and alpha 2 is 20 degrees and finally alpha 3 is 60 degrees. So I can start to find the assignment is to find the resultant of this system and find its direction and magnitude. First I'll find the magnitude and after I'll find the direction. To find the magnitude, I first find all the components in the x direction, and then after I'll find the components in the y direction, and then I'll use Pythagoras. But let's start out. First I'll find the fx component to f1. That must be from here to here. And the fx component to this one is from here to here. And the component in the x direction to this is from here to here. So I could set f1 in the x direction. That is cosinus 2 alpha 1 times f1. And it's a I don't take in consideration the direction yet. This I'll do later. I could take out the magnitude of f1x now, but I strongly don't need it. If I like it, then I just press the ordinary equal sign. That was f1x. Yeah, and now it's just to change, because now I can go down, take copies, because the second one, that must be cosinus 2 alpha 2 times f2. So this is f2x, and it's exactly the same procedure for the third f3. That is just cosinus 2 alpha 3, and it is f3. So now I had all three components in the x direction, and now I can do the same for the y direction for the different forces. So it's in principle just a copy of this. I could do it here like this, and now it's just to change the names. The y and the y, and now it's sinus values. And finally this one. Yeah. Now I'll take the sum for the one in the x direction, so I need to have a clever name. I think I'll name it just frx. Then I know it's the resultant in the x direction. And the first one here is positive because that's pointing to right. So I set f1x. For the second force, it's negative because it's pointing to left. So it's minus f2x. And it's also minus for the third force because it's pointing to left. Minus f3x. And then I can take the outputs. And the input was kilonewton, so the output should also be kilonewton. So I can conclude the resultant in the x direction is minus 1.2 kilonewton, so it's pointing to left. And if you look at the total picture here, I think that seems likely because two of the forces are pointing to left and only one to right. Yeah, now I'll do the same for the y direction. Fr in the y direction. That is, if I look at F1, then this component is positive because it's pointing upwards. So it's a plus value. For the second one, it's pointing downwards. It's the component to this one. It's pointing downwards, so that's a minus. F2 in the y direction. And for the last one here, F3, it's positive because it's pointing upwards, so that's a plus. And I can take out the value. It's kilonewton. So I can conclude the resultant in the y direction is positively. It's pointing upwards. And if you look at the picture, it seems likely because two of the forces is pointing upwards and only one is pointing downwards. So now I had the system, and now I'll draw a small sketch of this because that is needed, because now I need to find the magnitude and after the angle. Yeah, let's try to go to paint. It's not the best one, but better than nothing. Frx was pointing to left. So I'll try to indicate it here. And then the Fy was pointing like this, and it was bigger than Fx. It's amazing. Try again. Try. That was better. So now I have here Fx, and here I have Fy. And now the assignment is to find the Fr for this, and it is here. That's the resultant. It's not so easy to control, but I'll try again. Need to have it somewhere here. Yeah. This is Fr. So now I can give this name Fr. Yeah. Now I'll take a print screen of this. Yep. Now I can make Fr, find Fr, because if I use Pythagoras, I can see if I drag a help line like this, it's a right-angled triangle, so I can use Pythagoras. I simply can set fx squared plus fy squared should be equal to fr squared, and then I can find fr. So I'll make a guess of fr. I just set 1 kilonewton, and then I'll use Pythagoras. I'll set fx squared plus fy squared. Then I use the Boolean equal sign. Should be fr squared, and then I can ask for fr, and it cannot find fr. That was a little bit weird. I have already made a guess. This one is squared. Oh, it's not f. It's of course frx and fry. So on this drawing I have made a small failure because it should be frx and fry, of course. So I can conclude that the magnitude of fr is 3.389 kilonewton. So now I have the magnitude. So this is a result. Maybe I'll only take 2 decimals. Yeah, now I have fr. Now I just need to find the angle, and yeah, you could just say you find this angle here, and then just explain that this system is in the second quadrant. This is the first quadrant, this is the second quadrant. So I'll find this angle here, and because I know the magnitude of frx and fry, then I can use tangents to find this angle. Yes. So to find the angle, I'll simply just use tangents. I make a guess of alpha. Just set 1 degrees. And then given. And then I set tangents to alpha. Boolean equal sign. And alpha is here, and tangents is the opposite divided by the adjacent. So it's this one divided by this one. And because this is minus, then to be on the safe side, I'll use the numerical value of both. And to take the numerical value you can find in the calculator, and it's set the absolute value or numerical value of f. It was fry. Yes. And then this divided by, and then I take the absolute value again. And now it's frx. And then I can ask for alpha. And it's in radians, so I'll convert to degrees. And highlight. Normally all angles here is indicated by 3 decimals, so this is okay. So I can conclude the angle is 69 degrees, and I can give a note here in the second quadrant. Yeah, this was the first part of the assignment. Yeah, and the next one here, I'll take a print screen. Go to MatCat. principle is the same for assignment 2A. So yeah, I'll again I can strongly recommend you to make a sketch where you indicate the name of each forces. This is if I have decided this is F1, F2, F3 and F4. So I'll make all the inputs. F1 is 400 Newton, F2 is also 400 Newton, and F3 is 300 Newton, and F2 a little bit about as F4 is 200 Newton. So I check again, F1 is 400 Newton, F2 is 400 Newton, F3 is 300 Newton, and F4 is 200 Newton. Yeah, can make it a little bit closer this. Now I can also give the angles a variable name. So I choose alpha 1. That is 15 degrees, and alpha 2 is, now I need to take care because this was F1 and this is F2, so this is 45 degrees, and alpha 3 is 30 degrees, and finally alpha 4 is 60 degrees. But take attention, and again I'll strongly recommend you to make a sketch with the different numbers, because otherwise you can easily make a failure. Yeah, this was the input. Now I can find fx, the components in the x direction. So I'll start with f1x. This is the component to this one, and that must be cosinus 2 alpha 1 times f1. Yeah, and then the procedure is exactly the same for the other. In the first matter, I don't take in consideration the direction of the components. I just find the magnitude. So in principle now I can just take a copy of this and then rename and set the second one is cosinus 2 alpha 2 and then f2. So this is this component here for this one, and then for the third and the fourth. So that's exactly the same principle. We try again. F3x, and now it's alpha 3, and it's 3. And then the last one, the fourth, is cosinus 2 alpha 4, and then it is this one. Yes, so now I had the components for each force in the x direction. So now I just need to find it in the y direction, so I take a copy here and rename to the y. It's all over the y. And now it's just to take sinus value. Sinus. So now I had also the components for each force in the y direction. Now I can find the resultant for in the x direction, Fr in the x direction, and now I had to take in consideration the direction. The first one here is positive, pointing to right. So I'll take this one. And the second one here is minus for this one. So that's minus this one. Also for the third force it's minus because it's pointing to left. It's minus. And the fourth one is positive because that's pointing to right, so that's a +1. And now I can take out the magnitude, and the input what was Newton, so output could also be Newton. Yeah, it's an annoying bug this in MatCat, but if you scroll up and down, then it should disappear. This was FRX, and then it's FR in the y direction. And then I look carefully at the picture. This one was F1. That is positive, the component. So it's a plus value. And for this one, the component here is negative, so that's a -1. And then for this one, it's a plus value because it's pointing upwards. I'll take this one. And for this one, the fourth one, it's also positively. I'll take out, yeah. I think I'll just use integers here as output. It's a little bit more easy to read, and for MatCat it makes no problem because it still have the exact value. It's just the visible part here. So I can conclude that the resultant in the x direction is minus, and in the y direction it's positive. So it must be in the second quadrant. So I'll draw it in again a principal sketch in Paint. So this one is FRX is minus. Yeah, that was FX. And then I have this one is positive, pointing upwards. Yes. Give it name. FRY and FRX. To MatCat. A little bit smaller. So yeah, I missed to draw the last one, so I'll go back again here and then just have it. So I have all of it. So somehow I have FR here. This is FR. FR. Yeah, now I can take a print screen. This. Go to MatCat. That was better. First I'll find the magnitude of FR, and again as in the previous assignment it's just to use Pythagoras. So I make a guess of FR, set 1 Newton, and then I use given, then I set frx squared plus fry squared, Boolean equal sign, should be r squared. And then I can ask for fr. I use integer. And this is the final result. So, yeah, the resultant is 155 Newton. So this is FR. Now I'll find the angle here and then write a note that this is in the second quadrant. So I'll make a guess of alpha. I just guess 1 degrees given. And to find alpha here, I use, as in the previous assignment, I need to use tangents, because tangents is defined as the opposite divided by the adjacent, and the opposite is the same as fry, and the adjacent is frx. So tangents to alpha, Boolean equal sign, equal to, and because this is a minus value, then to be on the safe side, I use for both fry and frx the absolute value. So I set fr in the y direction, and then divided by, and then the absolute value of fr in the x direction. And then I can ask for alpha. And it's radians, so I convert to degrees. And this is the final result. Yeah, so this angle is 68 degrees, and that seems likely. It also seems likely that this is 155 Newton if you compare with fry and fxy. Yeah. And of course this angle is in the second quadrant, so I could make a note of this in the second quadrant.